You know, when you stand in the middle of a major city and just look up, there is this overwhelming sense of physical permanence.
Oh, absolutely.
You see these massive towers of glass catching the sunlight, the sweeping, intricate arcs of steel, and just the sheer brute weight of millions of tons of concrete holding the whole thing down. For our entire history, that has felt like the ultimate triumph of the visible world.
Yeah, it's an entirely visceral experience.
Right. You can walk up and touch it, you can photograph it, you can literally measure the shadow it casts across a city block.
And historically speaking, we've always judged a city's progress or, a society's advancement by the sheer scale of its visible skyline.
Oh, for sure.
The broader the concrete footprint, the taller the spire, the more advanced we just assume the civilization is. It's an industry built entirely on tangible, physical might.
But today, we're taking a deep dive into a concept that completely flips that assumption on its head. We are digging into some incredibly fascinating source material today. It's a manifesto-style release from Roots BIM LLC.
Right, they put this out on June 5th, right?
Yes.
To coincide with World Environment Day.
Yep, exactly. And their core argument is that the future of our skylines is not going to be defined by what we can see or how heavy the materials are. It is going to be defined by something completely invisible.
Which fundamentally shifts the stakes of the entire construction industry.
How so?
Well, because for thousands of years, the primary question in construction has simply been, what can we build? How high can we stack the stone? How wide can we stretch the steel?
Right, it's all about pushing the limits of physics.
Exactly.
Yeah.
But the source material outlines how that fundamental question has completely changed. It's no longer just about what we build, but how responsibly we build it. And to achieve that, they argue we need what they call climate intelligence.
Okay, let's unpack this, because the opening of this release is incredibly striking. It states right up front, and I'm quoting here, "Concrete shapes our skylines. Steel defines our strength. But the future of construction will be defined by something far less visible. Intelligence."
It's a powerful statement.
Yeah, it really is. And that sets up our mission for this deep dive. We are going to explore this concept of conscious engineering. We want to figure out how the industry is trying to shift away from just erecting these massive brute force structures to actually engineering them with climate intelligence baked in from the very first sketch.
It's a totally necessary evolution, honestly, because while you and I might stand on the sidewalk admiring the concrete and the steel, what we don't see, what is completely invisible to the person on the street, are the hidden environmental costs of getting those materials to that exact spot.
Yeah, the logistics of it all.
The sheer weight of the environmental impact behind a single skyscraper is staggering.
But, the core problem identified here isn't just that the impact exists. The problem is when the industry actually realizes it exists.
Right. The manifesto makes the claim that these massive environmental impacts are traditionally realized way, way too late in the process.
Way too late. We're talking about a system where by the time someone actually calculates the true environmental toll of a building, the design is already locked in, the final blueprints are stamped, the contracts are signed with the builders, and the materials are basically already loaded onto the delivery trucks.
Yeah.
And because of this massive delay in gathering the data, if you want to suddenly pivot and make the building greener, the cost to change the plan becomes astronomical.
And when a change becomes prohibitively expensive in a high-stakes, multi-million-dollar construction project, we know exactly what happens to it.
It gets scrapped.
It gets thrown out entirely. Sustainability stops being a core feature of the design and becomes a compromise. It turns into the very first thing that gets negotiated away at the 11th hour because, well, the financial budget simply cannot absorb the cost of a major pivot.
It makes me think of an analogy. Traditional construction, the way it's described here, it sounds a lot like a team of artists trying to paint a massive, intricate mural in a pitch-black room.
Oh, that's a good way to put it.
Yeah, you have people mixing paints, making these big, bold brush strokes, but no one can actually see the full picture. You only spot the glaring flaws when someone finally flips the lights on at the very end.
Oh, it's finished.
Exactly. But by then, the paint is completely dry. Fixing a mistake at that point doesn't mean just touching up a corner. It means scraping the whole canvas down and starting from scratch, which nobody has the time or money to do. But I do have to push back on this premise a little bit, or at least challenge the underlying logic.
For sure. Go for it.
Because from a purely capitalist financial perspective, aren't architects and developers already heavily incentivized to use the absolute minimum amount of material possible?
You would certainly think so.
Right. I mean, if steel is incredibly expensive and a structural engineer figures out how to use 20% less steel to save the developer millions of dollars, aren't they accidentally saving a massive amount of carbon too? Why do we even need the separate layer of climate intelligence if the financial budget is already putting a strict cap on imperial use? Wouldn't financial savings naturally lead to carbon savings anyway?
Well, what's fascinating here is how often financial cost and ecological cost actually diverge.
Really?
Yeah, it's a very common misconception that cheaper means greener. Let's look at the why behind the industry's traditional failures. The traditional building process isolates these disciplines into separate silos. You have architects dreaming up the geometry in one office, structural engineers calculating the load in another,
And procurement teams looking at a spreadsheet somewhere else.
entirely, all disconnected from each other. So to answer your question about the budget, let's say the procurement team needs 10,000 tons of steel. They find a supplier overseas that smelts steel using cheap, incredibly dirty coal power, and then they ship it halfway across the world on a diesel freighter.
Okay, I see where this is going.
Financially, that might be the cheapest option by a landslide, but ecologically, the carbon footprint of that cheap steel is catastrophic compared to buying from a local plant that uses electric arc furnaces powered by renewable energy.
Wow. Okay.
If you're only looking at the financial spreadsheet, if you're painting in the dark, as you said, you pick the high-carbon, cheap option every single time. The true ecological cost is only visible once the materials arrive on site, which is exactly the moment when it's impossible to send them back.
Ah, I see. So the financial incentive actually drives you away from the sustainable choice if you aren't tracking the carbon footprint simultaneously, which logically means if we know these hidden ecological costs are creeping up on us in the dark, we have to identify exactly what mechanisms drive them. We need to know what to track.
And Roots BIM LLC is very precise about this. They meticulously break down a triad of environmental costs.
The triad.
Yes, these are three crucial, distinct design phases that lock in a building's ecological fate long before the ribbon-cutting ceremony.
Right. The three pillars they focus on are material selection, which defines what they call embodied carbon. Then there's the MEP systems, which stands for mechanical, electrical, and plumbing. And those dictate the operational energy.
Correct.
And finally, the actual construction sequencing, which dictates the level of waste and emissions on the job site.
Those are the big three. And understanding the mechanics of how they differ is absolutely critical to understanding why the traditional siloed system is failing us.
Okay, let's demystify that jargon for a second, starting with the difference between the first two. Embodied carbon versus operational energy. The easiest way to visualize this is by looking at a car.
Okay.
Embodied carbon is like all the pollution, the mining, and the energy that was emitted by the factory just to manufacture the car. It's the iron ore pulled from the earth, the smelting of the engine block.
The shipping of the tires, the electricity running the robotic assembly line.
Exactly. All of that carbon is permanently embodied in the physical vehicle before you even put the key in the ignition.
Right.
On the other hand, operational energy is the gasoline the car burns or the electricity it draws from the grid. Every single day you drive it for the next 15 years.
That's a perfect analogy. And if we connect this to the bigger picture of a skyscraper, you start to see the immense gravity of a single Tuesday morning design meeting. In a building, the embodied carbon is the thousands of tons of poured concrete, the steel girders, the massive panes of glass. The operational energy is the HVAC systems constantly pumping air, the elevators running up and down, the lighting grids, basically the MEP systems.
Right. They are completely intertwined but require totally different strategies to manage.
Precisely. For example, if an architect decides on a bold, sweeping design that requires massive, highly complex steel reinforcements just to fight gravity, that is an immediate, permanent spike in embodied carbon.
Because they have to order so much extra steel.
Exactly.
Oh.
But then, let's say they decide to wrap that entire complex steel structure in a giant glass box.
Which looks great, but...
But glass is terrible at insulating. So, to keep the people inside that glass box from freezing in the winter or roasting in the summer, the mechanical engineers have to specify massive industrial-grade air conditioning and heating units.
Oh, wow.
That decision locks in a massive, lifelong drain of operational energy. The building will pull excess power from the city grid every single day for the next 50 years, all because of an aesthetic choice made in week one.
That is wild to think about. And then there's that third pillar of the triad, construction sequencing, the actual project schedule, which honestly sounds like a purely logistical issue, not an environmental one.
It is often overlooked by the general public, I'll give you that. But the mechanism of sequencing is a massive driver of environmental damage.
Yeah.
Waste and carbon emissions on a job site are not just inevitable byproducts of humans doing physical labor, they are direct, measurable results of how a construction sequence is scheduled and managed.
How so? Give me an example of how a bad schedule creates carbon.
Well, think about the choreography of a job site. If the supply chain isn't perfectly coordinated, you might have 50 diesel concrete trucks arrive on a Tuesday, but the rebar framing isn't finished yet.
Oh, no.
So those trucks sit there idling their engines for hours, pumping exhaust into the air, or consider material degradation. If the drywall arrives 3 weeks before the roof is sealed and a rainstorm hits,
The drywall is ruined.
yeah, exactly, gets tossed into a dumpster, hauled to a landfill, and the procurement team has to order a second batch, doubling the embodied carbon for those walls. Or the absolute worst case scenario, rework.
Rework.
Yeah. If the plumber's plans weren't coordinated with the structural engineer's plans, the plumber might show up and realize a concrete beam is blocking their main pipe route.
So they literally have to drill through the concrete they just poured.
You've got it. You are wasting energy and generating debris simply to undo a mistake that never should have happened. It all ties back to a lack of early integrated intelligence.
So we have this triad of costs: the embodied carbon locked into the materials, the operational energy locked into the MEP systems, and the sheer waste generated by chaotic construction sequencing.
Correct.
And as we established, traditionally, all of these are locked in during the design phase, while the teams are working in their separate silos, essentially in the dark.
Painting with the lights off.
Right. So the industry desperately needs a tool to turn the lights on. They need a mechanism to visualize and calculate these exact costs before they become permanent reality. And that brings us to the solution the source material advocates for: the evolution of BIM.
BIM, Building Information Modeling.
Right.
Historically, BIM was essentially just a 3D digital model. It was a step up from paper blueprints, but it was mostly used for basic clash detection. It was a way for the architect to see if the plumber's pipes were going to run straight through the electrician's wiring before they got to the site.
But the manifesto states that BIM has fundamentally evolved past that. It's moving from that basic 3D coordination phase into what they call true climate intelligence.
Yes, exactly.
The technology now unlocks highly advanced workflows that tackle the exact triad of costs we just discussed. They mention simulating energy performance before construction even begins. They talk about quantifying embodied carbon directly from the digital model, optimizing the materials, and ultimately aligning projects with strict ESG targets. That's environmental, social, and governance from day one.
This is the core of the paradigm shift. The digital model is no longer just a visual representation of the physical geometry. It is a fully functional, highly complex data ecosystem.
Here's where it gets really interesting to me. I think about this modern version of BIM like a highly advanced flight simulator, but for architects and engineers.
A flight simulator, I like that.
Think about how the airline industry trains pilots. They don't just put a rookie in a real multi-million-dollar jumbo jet, fill it with fuel, and say, hey, let's see what happens if you pull this lever.
That would be disastrous.
Yeah. Instead, they put them in a digital simulator where they can test the limits, face extreme conditions, and crash 1,000 times without hurting anyone or wasting a drop of real fuel.
And that is exactly what modern BIM is doing for the environmental budget of a building.
Right. Instead of crashing a real building's energy budget in the real world, where the concrete is already poured and the glass is already installed, they get to crash it in the digital simulator.
It's brilliant.
When an architect draws a steel beam on the screen, the software isn't just drawing a gray rectangle. It's pulling from a database that calculates the exact carbon footprint of that specific grade of steel.
Exactly right.
So if the carbon score is too high, they can tweak the variables. They can swap out the steel beam for engineered mass timber, or change the angle of the windows to reduce the summer heat load, and instantly watch the operational energy requirements drop in the data panel. They keep tweaking the design in the simulator until the building flies perfectly.
You're testing the physical and environmental limits of the structure in a zero-risk environment. It allows for rapid iteration based on ecological data, not just aesthetics, but the implications of that shift are profound for how the industry is governed.
Well, I do have to play devil's advocate here, though.
Go ahead.
We have all this amazing granular data in the simulator now. We can see the carbon footprint down to the exact gram of carbon per square foot, but does just having this data actually guarantee a greener building?
What do you mean?
Or does it just give us more numbers to look at in our meetings? I mean, a greedy developer could look at the simulator, see the terrible carbon score, realize the high carbon materials are slightly cheaper financially, and just shrug and build it anyway, right?
It's a fair question, but it misses a fundamental structural change in how commercial real estate and construction are financed today. The source material hits on something vital here. Sustainability is no longer an external layer or a PR spin. Because of this data, it is engineered into the core of the project lifecycle.
Okay.
And the mere presence of that data forces ultimate accountability. In the past, a developer could plead ignorance. They could legitimately say, we had no idea the carbon footprint would be this high until the building was finished.
Plausible deniability.
Exactly. But you cannot plead ignorance when the digital model quantifies the exact embodied carbon footprint of the entire structure before you buy a single bag of cement. And when you tie this to the ESG workflows mentioned in the release, that data trail becomes legally and financially binding.
Wait, really? How so?
Because today's major investors, zoning boards, and corporate tenants are strictly demanding ESG compliance. An investment fund won't finance a new office tower unless it meets specific net zero targets.
Oh, I see.
In the past, a developer can just promise it would be green. Today, the investors demand to see the BIM data. The digital model provides the irrefutable mathematical proof. You can't just claim your building is sustainable. The simulator proves whether it is or isn't before ground is broken.
Which brings us to a really uncomfortable realization about the buildings we already walk past every day and just assume are green. Because sustainability is now integrated into the core data of a building, it forces a radical redefinition of what an eco-friendly building actually looks like. And this brings us to the core philosophy of Roots BIM LLC.
There's a powerful quote in their release that crystallizes this entire shift. They state, and I quote, "The most sustainable building is not the one that looks green, it's the one that performs intelligently."
So what does this all mean? I want you to really think about your own mental image of eco-friendly architecture. If I say green building, what pops into your head?
Probably a sleek, futuristic glass tower with a bunch of trees planted on the balconies.
Right. Maybe some lush ivy growing up the side of the concrete. It looks like a vertical forest in the middle of a metropolis.
It is the popular aesthetic of environmentalism. It signals to the public that the building cares about nature.
But the incredible irony is that those buildings might feature these superficial green aesthetics like decorative plants on the facade, but structurally they might be absolute environmental disasters.
Oh, absolutely.
Think about the hidden triad of costs we just walked through. To hold up thousands of pounds of wet soil, massive planters, and full-grown trees on a 40th floor balcony, you have to drastically increase the structural support of that balcony.
Which means pumping massive amounts of extra concrete and heavy steel reinforcement into the frame.
Right.
Right.
Which causes an immense spike in the embodied carbon. You are doing more damage to the earth mining the steel than those decorative trees will ever offset in their lifetime.
A net negative.
And then, as we discussed, maybe the glass facade behind the trees is terrible at insulating, so the MEP systems are working overtime, draining operational energy from a coal plant just to keep the lobby comfortable. But hey, it has bamboo on the roof, so it looks green.
This raises an important question about our priorities moving forward. The manifesto explicitly frames this within the era of climate urgency. And in an era of climate urgency, visual aesthetics are entirely irrelevant compared to measurable, engineered performance.
It's all about the data.
Exactly.
Yeah.
A truly sustainable building might look like a very standard, unassuming, almost boring brick structure. But if it was designed using advanced climate intelligence, if the simulator optimized the materials to slash embodied carbon, and the MEP ductwork was routed so perfectly that it uses near zero operational energy, then that boring-looking building is infinitely greener than the glass tower covered in decorative shrubbery.
It is a total paradigm shift. We are moving from performative sustainability to intelligent performance. It's no longer about the optics. It is entirely about the math.
And that math has to be done early, with the lights on, not in the dark.
Okay, let's step back and look at the whole picture we've uncovered today. We have journeyed from an industry that has historically relied on the brute, visible strength of concrete and steel to one that must now be driven by this invisible force of climate intelligence.
It's a huge leap.
It is. We saw how the traditional silos kept the hidden weights of our skylines, the embodied carbon, the operational energy, the chaotic construction waste hidden in the dark until it was far too late. It turned sustainability into an expensive last-minute compromise that usually got cut.
Right.
But by leveraging these advanced BIM workflows, by treating the digital model like a flight simulator to stress test energy and carbon early, the industry is flipping the script. Sustainability isn't an external layer of decorative plants anymore. It is engineered into the very core of the data, perfectly aligned with the financial and net zero targets of the future.
It shifts the entire foundation of how we conceive, design, and justify a physical structure.
So I want to leave you with this. Take a second right now and just look around the room or the building you are currently sitting in. Look at the drywall, the ceiling panels, the unseen structural supports holding up the floor above you. I want you to wonder about the hidden embodied carbon surrounding you in this exact moment.
It's everywhere.
Was the space you are occupying simply constructed through the traditional blind brute force of the past? Or does it answer the ultimate question posed by today's deep dive? Is it consciously engineered?
And to take that one step further, consider where this data-driven accountability is inevitably heading. If modern BIM can now perfectly simulate and quantify a building's entire carbon footprint and operational energy before a single brick is ever ordered, well, will we soon see a future where city governments and zoning boards completely deny construction permits to any digital model that fails to hit strict net zero targets in the simulation phase? Could a failing grade in the digital flight simulator mean a physical building simply never gets built at all?